Hi everyone! Last week we talked about projectile motion. We also mentioned that projectile motion, it refers to a body that is thrown in a curved path with constant acceleration. And that means that it is influenced only by gravity. We also discussed the different terms that will be used in projectile motion. These are projectile, trajectory, and range. We've also emphasized that the horizontal component and vertical component of a projectile are independent from each other. Thus, we are to evaluate the motion in each component separately. When we say independent to one another, it simply means that changing one component does not affect the other. So again, throughout the motion of a projectile, change occurs only in the vertical component of velocity. It is due to the fact that it is influenced only by gravity. And the result of combined motions in the horizontal and vertical component is the parabolic trajectory. In our previous lesson, we focused on projectile launched horizontally. This time, we will focus on projectile motion launched at an angle. Projectile launched at an angle. Observe the video clip. Alright, so when we say projectile launched at an angle, it is when a projectile fired at an angle above the horizontal rises to some maximum height and then descends. This projectile motion is a combination of uniform horizontal velocity and a body thrown up. This time, let's now analyze the horizontal component and vertical component of velocity, acceleration, displacement, time, and angle. Since as mentioned, we are to evaluate the motion in each direction or component separately. Let's analyze first the velocity. I want you to observe the video. Again, the length of the arrow, it indicates how fast the object is moving in that direction. As you can see, horizontal velocity is always constant, while vertical velocity is not constant since it is affected by gravity. So how are we going to find the horizontal component and the vertical component of the velocity? Let's go first to the horizontal component. To find the horizontal component of velocity, we will use this equation or formula. Initial horizontal velocity equals initial speed multiplied by cosine theta. So if we're going to find the initial horizontal velocity using the video, since the speed is 60 meters per second, so that means 60 meters per second, which is the initial speed, multiplied by the cosine 60 degrees. So if we're going to calculate that, the answer will be 30 meters per second. That means the initial horizontal velocity is 30 meters per second. And as mentioned, since the horizontal component of velocity is constant, therefore we can say that the final horizontal velocity and the initial horizontal velocity will just be equal. So that means the final horizontal velocity is also 30 meters per second based from the video clip. Let's now go to the vertical component of velocity. As mentioned before, For projectile launched at an angle, it is a combination of uniform motion and free fall, specifically body thrown up. So that means it has two parts for the vertical component. That would be the upward motion and the downward motion. So in order for us to know the vertical component of velocity, we will use this formula. Initial vertical velocity equals initial speed multiplied by sine theta. So if we are going to look at the video clip, that means our initial speed is 60 meters per second. In order for us to find the initial vertical velocity, we will just multiply the initial speed, which is 60 meters per second, multiplied by sine 60 degrees. And our answer for that is approximately 52 meters per second. So that means our initial vertical velocity is 52 meters per second. So if you are to observe the video clip, as mentioned as well in our previous lesson, at the maximum height, the speed for that is equal to 0. So if we are to focus on upward motion, that means the final vertical velocity is equal to 0. Let's focus on the downward motion. So that means we are to start at the maximum height going downward. Remember, at maximum height, the velocity for that is equal to 0. That means our initial vertical velocity, which is going downward, is equal to 0. And going down, it is increasing. Now, if you've remembered the speed symmetry, you'll know that the speed of the projectile at any height above the starting point on its way up is actually equal to its speed at the same height on the way down. The only difference for that is the sign, since the velocities going down are negative since the motion is going downward. Let's review the velocity of a projectile launched at an angle. So this diagram, it actually illustrates the changes in horizontal and vertical velocities of an object in projectile motion. The maximum height and range, which is also the horizontal displacement, are displayed. So as you can see, the horizontal velocity is represented by the red arrow, while the vertical velocity, it is represented by the green arrow. So in any projectile motion, vertical velocity decreases in magnitude. So as you've seen, the vertical velocity shortens because when the projectile is traveling upward, it is against gravity. And at the maximum height or at the tip, the vertical velocity is 0. When the projectile is traveling downwards, since it is in the direction of gravity or in the same direction of gravity, the vertical velocity changes its direction and it increases its magnitude. As you can see, the arrow for the vertical velocity increases or lengthens. However, for the horizontal velocity, the direction and magnitude remains constant. This time, we are to combine the horizontal component of velocity and the vertical component of velocity. Earlier, we analyzed the horizontal component of velocity, in which we are referring to this portion. And we also analyzed the vertical component of velocity, in which we are referring to this portion. So if we are to combine the x component of velocity and the y component of velocity, we are actually referring to this portion. So how are we going to find the velocity if we are to combine the horizontal component of velocity and the vertical component of velocity? So we will use this equation or formula. That's VO, which is the initial speed, equals the square root of initial horizontal velocity squared plus initial vertical velocity squared. Earlier, we've mentioned that the initial horizontal velocity based from the video clip is 30 meters per second. How did we get that again? Using this equation or formula. Again, the 30 meter per second, we are referring to this velocity. And we've also mentioned that the initial vertical velocity is approximately 52 meters per second. Again, this is based from the video clip. How did we get that? So, using this formula. And of course, we are referring to this part. So, if we are to find the initial speed, say for example, we don't know that it is 60 meters per second. We only know that the initial horizontal velocity is 30 meters per second and the initial vertical velocity is 52 meters per second. If we are to find the initial speed of the projectile, we are referring to this portion. So just substitute the given to the formula, so that will become VO equals square root of 30 meters per second squared plus 52 meters per second squared. If you are to simplify that, the answer is actually 60 meters per second. So that is the initial speed of the projectile. And if we are to find the final speed of the projectile, we will use this formula. V, or the final speed, equals the square root of final horizontal velocity squared plus final vertical velocity squared. Let's proceed to acceleration. The blue arrow, it indicates the acceleration of the projectile, while the length of that arrow, it indicates how fast the object is moving in that direction. So as you can observe, for the horizontal component, in the absence of zero resistance, it actually experiences no acceleration at all. Again, for the horizontal component, acceleration is zero. Now, for the vertical component, since it is affected by a constant acceleration due to gravity, which is equal to negative 9.8 meters per second squared, this acceleration is always constant and always acts downwards. Since the acceleration or the vertical component of acceleration is constant, what's the use of this formula that I've presented? This is for us to use if we are to find the final vertical velocity or initial vertical velocity or time. So if we will focus on the upward motion, we will use this formula. Acceleration equals the final vertical velocity, which is equal to 0 for the upward motion, minus initial vertical velocity divided by the time going up. If we will focus on the downward motion, we will use this formula. Acceleration equals final vertical velocity minus initial vertical velocity, which is equal to 0 if we are to focus on the downward motion, divided by the time going down. So again, this formula that I've presented, we will use it if we are to find the final vertical velocity or the initial vertical velocity or the time going up or time going down. Let's now analyze displacement. So how are we going to find the displacement for the horizontal component and vertical component? Let's focus first on the horizontal component, which is known as the range. So we will use this formula. X equals final horizontal velocity times time, or X equals initial horizontal velocity times time. Again, as mentioned, the final horizontal velocity is just the same with the initial horizontal velocity. Now, what if you don't know the initial horizontal velocity or the final horizontal velocity? Then, we are to use this equation. X equals initial speed multiplied by the cosine theta times the time. How about for the vertical component of displacement? So let's focus first on the upward motion. We will use this equation. Y equals initial vertical velocity multiplied by the time going up plus 1/2 gt squared. Be very careful with the time because we will use the time that is going upward. What if you don't know the value of time? So how are you going to find the vertical component of displacement? We will actually use this equation or formula, which is 2gy equals final vertical velocity squared minus initial vertical velocity squared. How about if you are to find the maximum height that is reached by the projectile? So we will use this formula. That's y max or y at the maximum equals negative initial vertical velocity squared divided by 2g, or y max equals 1/2 gt squared. Let's proceed to time. So how are we going to find the time of flight? So if we are to focus on the upward motion only, we will use this formula. So this is for us to find the time going up only. So that's T up, or time going upward, equals negative initial vertical velocity divided by g. And if you've remembered, we have time symmetry, which is time going upward is equal to time going downward. If we are to find the total time of flight, we will use this equation. Total time of flight equals the time going up plus the time going down. What if we don't know the angle of projection? So we will analyze the angle, and if we are talking about angle, we are referring to this portion or the angle of projection. So to find the angle, we will use this equation. And in our previous example, based from the video clip, we've analyzed that the VOY, or the initial vertical velocity, is approximately 52 meters per second. And for our VOX, or the initial horizontal velocity, it is 30 meters per second. If we are going to substitute that to this formula, the answer is actually 60 degrees. Let's go to the sample problem. The initial horizontal and vertical components of the velocity of a projectile are 6.0 meters per second and 8.0 meters per second respectively. Find the projectile's initial speed, angle of projection, time of flight, maximum height, and range. So let's try to visualize the problem. 6.0 meters per second, and we are referring to the initial horizontal velocity. Next is the 8.0 meters per second, and we are referring to the vertical component of velocity. So for the first question, we are to find the initial speed, or the VO. So that means we are to combine the horizontal component and the vertical component of velocity. So what's the formula that we're going to use? Initial speed, or VO, equals the square root of initial horizontal velocity squared plus initial vertical velocity squared. So just substitute the given to the formula, so that will become VO equals the square root of 6.0 meters per second squared plus 8.0 meters per second squared. If we're going to simplify it, the answer is 10.0 meters per second. Again, everyone, I want you to solve it on your own as well, so that you will be able to follow along the process. So for the second question, the problem is still the same. This time we are asked to solve for the angle of projection. So what's the given? So the given will still be the same. The formula that we're going to use is this one. So let's try to substitute the given to the formula. And what do you think is the final answer? So our answer for this question is the angle of projection is equal to 53.1 degrees. Let's now go to our third question. And this time we are asked to find the total time of flight. The formula that we're going to use is T total equals the time going up plus the time going down. But we don't know the time going up or the time going down. So how are we going to find it? Remember the time symmetry. Time going up is just equal to the time going down. So in order for us to find the time going up, we will use this equation. So that's T up equals negative initial vertical velocity divided by G. So substitute the given to the formula. That's T up, or time going up, equals negative 8.0 meters per second divided by G, which is equivalent to negative 9.8 meters per second squared. Simplify, and our time going up is 0.816 seconds. So in order for us to find the total time, since we are asked to find the total time of flight, we will just add the total time going up and the time going down. Therefore, the answer is 1.63 seconds. Let's go to our fourth question. We are asked to find the maximum height. So that's Y maximum, or y at the maximum. Therefore, the formula that we're going to use is y maximum equals negative initial vertical velocity squared divided by 2g. So just substitute the given to the formula. Y maximum equals negative 8.0 meters per second squared divided by 2 times negative 9.8 meters per second squared. And it will become negative 64.0 meters squared per second squared divided by negative 19.6 meters per second squared. Simplify, the answer is 3.3 meters. That is the maximum height reached by the projectile. Last question. We are asked to find the range. So there are actually two formulas that we can use to solve for the horizontal component of displacement. First one is x equals VOX, or initial horizontal velocity times time. This second formula that I'm going to introduce, we are going to use it if we don't know the value of VOX. So the formula is x equals initial speed multiplied by cosine theta multiplied by the time. So let's substitute the given. Let's proceed first with the first formula. So that will become x equals 6.0 meters per second, since that is the VOX, multiplied by the time, which is 1.6 seconds. And if we're going to go to the second equation, that will become x equals the initial speed, which is 10 meters per second, and the cosine theta, or multiplied by the cosine of 53 degrees, multiplied by the time, which is 1.6 seconds. And then if we are going to simplify both of the equation, we will actually have the same answer, which is 9.6 meters.